Today we're going to be studying how to multiply polynomials. And the first two examples he gives us, I'm not going to go into it too much because we've already done similar things. What he does is he puts a monomial, that is a single term, outside the parentheses, and then we multiply it times the trinomial. And I think we know how to do this. I hope so. The first term is going to be what? 4 times 2, that's going to be 8. And x cubed times x squared is going to be x to the 5th. Remember, we're adding our exponents. Okay, and so the next term would be 4x cubed times negative 8x. And so our answer is going to be negative. 8 times 4 is 32. X cubed times x is going to be x to the 4th. And our last term is going to be 4x cubed times 11. And that's going to leave us with 44x cubed. And I think we've done similar things to that, so I'm not going to spend a lot of time on that. I want to get into polynomials times polynomials. And we're going to start with binomials. So we're going to multiply a binomial times a binomial. Now when I say binomial, boy, that better jump right into your head that we're talking about two terms. So we're talking about a system of two terms times a system of two terms. We're not going to be talking like that anymore. We're going to be saying a binomial times a binomial. By the way, a binomial times a binomial is a trinomial. Now there's one exception to that, and we're not going to be getting into it in this lesson. I think it's the next lesson or maybe the lesson after that we're going to get into what the exception is. But if you multiply a binomial times a binomial and you end up with a binomial, you probably have a problem. A binomial times a binomial is a trinomial. Could be a quadnomial, that is, it could be a polynomial with 4 terms. But let's work with this. Now, he does 3 systems of multiplication. The first system, you can read about it in the book if you like. To me, it is so archaic that it is completely unhelpful. Archaic. That word means it's old. It may have been useful at one time, but because of modernization, it is no longer valuable. It is no longer useful. That's what archaic means. And so the first system he uses is not my favorite system. Actually, the second system that he uses. We're going to be studying 2 systems. So the first system that we're studying today is FOIL. It is not my favorite system. It is the favorite system of most people. And I'm going to show you later why it's not my favorite system. But let's look at FOIL. FOIL is a system of multiplication where we multiply the first terms first, then we multiply the outside terms, then we multiply the inside terms, then we multiply the last terms last. So I drew a bar there so there'd be no confusion as to what the first terms are. The first term in this parentheses is 4x. The first term in the next parentheses is 3x. So we're going to multiply first terms, FOIL, first terms first. And that would be 12x squared. You didn't put 12x, did you? It's 4 times 3 is 12, and x times x is x squared. Be real careful of that. Okay, FOIL, we did our first terms. O, our outside terms. That's right, 4x and negative 2y. If we're looking at all these terms, what's the outside term? This is the farthest one out in this direction, and this is the farthest one out in that direction. So if that's helpful, those are the outside terms. And that gives us negative 8 xy. I hope you can see that 4 times negative 2 is negative 8. X times, well, there isn't anything to multiply x times, so just put that there, and nothing to multiply the y times, so x times y is just xy. And now we're going to do inside terms. Again, if we're discussing all 4 terms, the innermost terms, the inside terms, would be these two. That and that would be the outside terms, and these two would be the inside terms. So let's multiply those. That's right, 7 times 3 is 21, and y times x is yx. Now let's do the last terms. And we got 7y times negative 2y, and that's going to equal negative 14y squared. And I hope you put that square after y because we multiplied 7 times negative 2. That's negative 14. And y times y squared. Make sure you just keep track of your polynomials and your exponents. Make sure you get those right. And now, are there any like terms to add? Let's see, x squared, there's no x squares here. xy, there's no xy's here. And y squared, there's no y squared, so we can't add any. Wait a second. That's out of alphabetical order. Don't do that out of alphabetical order. Now, I did that to show you what can happen. You're looking at xy here and yx here, and they look like two different terms, and they're not. Okay? And if you would have put that in alphabetical order, you wouldn't have had that problem. So shame on you. Don't do that again. Well, there you go. That's much better. xy, and now we can add these terms. Negative 8xy plus 21xy, 13xy, positive 13xy, and that is our answer. Now, I hope you saw as we were doing this that there's a real methodology to all of this. As far as the exponents go down, the variables need to be in alphabetical order. Now, I've dealt with books that don't put variables in alphabetical order, and you can get into trouble doing that. And you'll never be counted wrong for doing it in alphabetical order, and you might be counted wrong for not doing it in alphabetical order. So make sure you do that. Now, I said that the exponents go in descending order, didn't I? And that's not what's happening here. We got an x squared here, and shouldn't our y squared be in the middle? No, it doesn't work that way. What we do is with our x's, when we have two different variables, our x's will descend. That is, the exponents of our x's will descend from cubed, squared, x, units, actually not units. And then we start ascending when we deal with the second variable. So it's going to be y, or xy in this case, up to y squared. And sometimes we can't do that. Sometimes it gets real messy and sloppy. But in this case, we can. So our x squared is going to be first, and our y squared is going to be last. But if we had any units, it would be after all of that. So that's just something to know for the future. And let's do another problem. Okay, this is the third system that he shows us. It's the second system that I'm showing you because I'm only showing you two. And it's my favorite system. It's called multiplying by rows. And this seems pretty simple. I mean, we were doing this in the 5th grade, weren't we? And what did we do? When we had two numbers, we put them in rows like this. We put the 32 up here. We usually put the smallest one on the bottom. You don't have to, but I don't know, that's what I was always told to do. And what do? We start from the bottom, and we start from the right-hand side. Just the opposite of reading, right? From reading, we go from left to right, right? In math, we're usually going from right to left. And we won't get into why that is. But sometimes you'll see mathematicians multiplying from left to right. Drives me nuts. And you can do that if you want. But this is what I learned in the 5th grade, and I'm sure you did too. So why don't we just keep doing the same thing? Okay, so what is our right-hand number on the bottom? It's 2. So let's multiply it times, multiply it times the upper right. So 2 times 2 is 4, and moving from right to left. 2 times 3 is 6. And hopefully what I'm telling you is just repeating. But what's in this column? This is the unit space. And what's in this column? It's the tens place. And if we had another column, it would be the hundreds place, thousands and 10,000s, on and on like that. I'm keeping this real simple so that you'll understand what we're going to be doing when it relates to binomials. But anyways, we have finished multiplying the 2, so let's multiply the 1. And it's really not a 1, is it? It's a 10, because it's in the tens spot. But just to keep it simple, we multiply times 1. And we multiply our 1 times the top. And where do we start? Same place. On the right-hand side. That's right, 1 times 2 is 2. We didn't put it here. We didn't put it in the units place because it's not going to have a units value. And I know maybe I'm over-explaining this, but like I said, that's not a 1. It looks like a 1, but it's not. It's a 10, isn't it? This is 10 plus 2, right? It's 12, okay? So this is in the tens spot. So if I'm multiplying the 10 spot, a 1 in the 10 spot, times 2, it's not 2, it's 20. And we just write 2, and we skip this spot here. I hope I'm not getting too complicated here. But I think you remember skipping this first spot, and sometimes people put a 0 in there. That's okay. I never did. Don't like to do that. You can if you like. I have a lot of students who like to do that. So anyways, we skipped that first spot as we went to the next row. We're going to see in the future that that's important when we're dealing with binomials also. Okay? And so what is the last one we do? We're going to multiply that 1, which you and I know is a 10. We're going to multiply that 1 times 3, which you and I know is really a 30. And so 1 times 3 is 3. And of course, you and I know that that's really 300, but we just write a 3. Keep it real simple so we don't have to overthink this, which I have completely done. I've completely overthought this. I'm just trying to explain what we're doing. So there you go. That's our answer, isn't it? Of course it's not. We've got to add that all together. Remember when we were doing FOIL, we had to add things together? And what are we adding together? We're adding like terms. Are there any units to add except for the 4? No. Are there any hundreds to add besides the 3? No. Are there any tens to add? Well, yeah. And you notice, like I promised you, this is going to be the hundreds, this is going to be the tens, and this is going to be the units. And that makes it real easy to add this, and you don't have to guess which of these 4 numbers we have to add together. We're just going to add straight down. Now that's it. We've done everything that we can, and that is our answer, 384. And boy, that was a long way to go around, and I spent a lot of time teaching you something that hopefully you already knew. If you don't know, you're in trouble. And it's something we learned a long time ago. And we're going to see why that's helpful. Okay, we're going to take that same problem that we multiplied with FOIL, and instead of multiplying it like this, that's a format that's good for FOIL, we are going to multiply in rows. So we're going to take the second binomial right here, and we're going to place it right under the first binomial. Just like that, and that's why we call it multiplying by rows. And look, we have the x's in one column. We have the y's in another column, so that's useful. And when we're multiplying like this, we do not need those parentheses. So that's what it's going to look like when we start. And in the book, Mr. Wallace puts a tiny little X out here to show you that we're multiplying. I don't know. We're in the 9th grade now, and I think when I see something like that, I know that we're going to multiply. In any event, if I put an X out there, I might confuse that with the other X's that I'm multiplying, so I'm not going to put an X out there. But just like the units, I'm going to start backwards. I'm going to be working from the bottom. You know, when you read, you start from the top, right? When you multiply, you start from the bottom. And when you read from left to right, right? And with math, you work from right to left. So you do everything backwards. And I think that's okay, because like I said, we've been doing that for I don't know how many years now. So let's start at the bottom. Let's start on the right-hand side. And negative 2y times 7y is negative 14y squared. And negative 2y times 4x is negative 8xy. Okay, so we're done with the bottom now, and as you can see, this didn't work out perfectly because we got the xy in the x column, and we got y squared in the y column. So that didn't work out perfectly, but it's going to be okay as we move along. And so we're still working on the bottom, of course. Everything's going to be from the bottom. And so 3x times 7y is 21xy. And isn't that nice that our xy's ended up in the same column? So we're not going to have the problem that we had before, where there might have been a little bit of confusion about adding our xy's. And then our last terms would be, starting from the bottom again, 3x times 4x. And that's going to be 12x squared. And as you can see, that's going to be real easy to add down, and let's do that. Okay, and that's our answer. And as you saw, I kind of went diagonal a little bit, not too badly, but I did a little bit. You're going to find out that I'm a real stickler for keeping everything in the proper column so that we don't start doing this routine and it's impossible to follow our work. Because if you've made a mistake or something doesn't look right, if you keep everything in the proper column, it's going to be a lot easier. So I got a little out of my columns because I kind of ran out of space here. So I cheated a little bit, but I guess that's okay. I hope that's okay. And now let's try one last problem. We're going to multiply a binomial times a trinomial, and you're going to see why FOIL doesn't work. Now, Mr. Wallace says he still uses FOIL, but he uses a different system of FOIL, which is a whole new system to use. And the way I do it is the same exact way, keeping everything in their proper columns. And so you don't need to use a new system. His way, or I shouldn't say his way, but the FOIL way, you're basically using a new system. And who in the world wants to do that? So let's do that. So we have a binomial times a trinomial, and we're going to put the smaller polynomial on the bottom. And as you can see, everything is in the proper column. Units, x's, x squares, or you can do that backwards if you like. So let's multiply that out. What are we going to do? Negative 5 times everything up here. And let's just, instead of going through that one by one, let's multiply that negative 5 by everything in the trinomial. Okay, and you can see that the way that multiplied out, everything's in the proper column. Units, x's, x squares. Now let's multiply our 2x squared by everything up here. And everything ended up in the proper column because we skipped the first space first, just like we did when we were multiplying units in the 5th grade. Skip that first space. And usually, not always, but almost always, everything else is going to end up in the right space. And look, we got units all the way up, x's all the way up, x squares all the way up, and we even, in our next column, is our x cubed. And so, and as we go out this way, we're always going to have our exponents with the proper exponents in the proper columns. So let's add all that. And that's how that ended up. And as complicated as that might look, if you start doing that with FOIL or that other archaic system, you're going to be in a lot more trouble than this. To me, this looks pretty simple. I mean, again, this is kind of what we did in the 5th grade. We multiplied 2-unit system times a 3-unit system times 112 or whatever. And everything ends up in the proper column if you do it right. Now let's do one last problem. Actually, we're not going to even do this problem. I'm just going to show you how to do it, because we're starting to repeat ourselves quite a bit. And what we're going to do here is when you have like 1 unit outside 2 binomials, what you do is you multiply the binomials first. Multiply this binomial times that binomial. And you already know how to do that. When you're finished, multiply everything. Multiply your answer to this times 3. Okay, and the reason why you do it in that order is because students often take this 3 and they multiply it times everything. Well, if you do that, you're multiplying everything times 9. I think it's 9. But you're multiplying this times 3, and you're multiplying this times 3. And if you think about it, now you're multiplying 3 times 3. If that's confusing, just remember, do the binomials first, and then do that. And that is the end of this lesson. Do your homework. Boy, you better do your homework.